How are you, all of you? I am Thomas Kantaye from Federal Technical and Vocational Training Institute. Have you seen the previous videos what I have uploaded? Okay. In today's class, we'll see about capacitor. That is the next topic related to the capacitor. We have seen about types of capacitor in the previous class. Right now, let's see what is the capacitor characteristics and capacitor color code. What is the capacitor characteristics? Do you know about characteristics of a capacitor? The characteristics of a capacitor define its temperature, voltage rating, capacitance range, as well as its use in a particular application. For different applications, different capacitors are used. Even though two capacitors may have exactly the same capacitance value, they may have a different voltage rating. If a smaller rated voltage capacitor is substituted in the place of a higher rated voltage capacitor, the increased voltage may damage the smaller capacitor. So even though the capacitance value is the same, if the voltage rating is different, we should select the appropriate voltage rating. The capacitor, as with any other electronic component, comes defined by a series of characteristics. It's its own a series of characteristics. These capacitor characteristics can always be found in the datasheet that the capacitor manufacturer provides. So we should observe or we should read the manufacturer's datasheet while we are substituting some capacitors for a maintenance purpose. The first capacitor characteristics is a nominal capacitance. So what does mean nominal capacitance? The nominal value of the capacitance C of a capacitor is the most important of all capacitor characteristics. In the manufacturer datasheet, we will observe the nominal capacitance as well as it may be printed on the capacitance body. So you will see the nominal capacitance. So it may be, this value may be measured in picofarad or nanofarad, or it may be microfarad, and is marked onto the body of the capacitance as numbers. It may be as numbers, or it may be as letters, or it may be colored bands. We'll see how we'll read these color bands or letters or numbers from the capacitors in the next topic. The capacitance of a capacitor can change value with the circuit frequency. Or it may be with the ambient temperature. The ambient temperature and the frequency is very important. While we are seeing the nominal value, it may vary by this nominal temperature or by a frequency. A smaller ceramic capacitance can have a nominal value as low as 1 picofarad, while larger electrolytic capacitors, we have seen the types of capacitors in the previous class, that it may be a ceramic or electrolyte type, can have a nominal capacitance value up to 1 farad. All capacitors have a tolerance rating that can range from minus 20% up to 80%, plus 80%. So for aluminum electrolyte, affecting its actual or real value. So the choice of a capacitance is determined by the circuit configuration, but the value read on the side of the capacitor may not necessarily be its actual value. It may vary by different factors, as I have already mentioned. It may be by ambient temperature, or it may be by the frequency of the source, or due to its tolerance. So the nominal capacitance value is very important. Very important. The other capacitor characteristics is working voltage. The working voltage is another important capacitance characteristics that defines the maximum continuous voltage, either DC or AC, that can be applied to a capacitor without failure during its working life. Generally, the working voltage printed onto the side of a capacitor body refers to its DC working voltage. We call it WVDC. It is working voltage DC. DC and AC voltage values are usually not the same for a capacitor, as the AC voltage value refers to the root mean square value, and not the maximum or the peak value with that is 1.414 times greater. Also, the specified DC working voltage is valid within a certain temperature range. If the temperature varies, it will affect the working voltage of that capacitor. Any DC voltage in excess of its working voltage or an excess of AC ripple current may cause a failure. It follows, therefore, that a capacitor will have a longer working life if operated in a cool environment and within its rated voltage. The capacitor should operate within a nominal temperature as well as within its working voltage range. The other characteristics of a capacitor is tolerance. What does it mean, tolerance? Do you remember about tolerance while we are talking about resistors in the previous class? Here also in the capacitors, tolerance is very important. As with resistors, capacitors also have a tolerance rating expressed as a plus or minus value, either it may be in picofarad or low value capacitance, generally less than, it may be 100 picofarad, or as a percentage, it may be expressed as a percentage for higher value capacity, generally higher than 100 picofarad. So it may be expressed in terms of picofarad plus or minus, or it may be in the percentage. The tolerance value is the extent to which the actual capacitance is allowed to vary from its nominal value and can range anywhere from -20 up to plus 80%. So if you didn't observe the tolerance of your capacitor, you will not get the exact nominal value. Rather, it may be plus or minus the tolerance. So you may read if for the time being, if you have 100 microfarad capacitor with a tolerance plus or minus 20, you will read, or by using your measuring instrument, you may read between 80 or it may be 120 microfarad. That means if it is a plus, if it is 100 plus 20, it will be 120, and if it is minus 100 minus 20, it will be 80 microfarad. So you may read between 80 and 120 microfarad. So you should observe while you are selecting your capacitor for your circuit design, you should observe the characteristics, the main characteristics, that is the tolerance of your capacitor. The other characteristics is a leakage current. What does mean leakage current? What is, as you remember from the previous class, in between the two plates there is a dielectric material. That dielectric material will block the flow of current. But while we are applying a voltage across the two plates, some leakage current may move between the dielectric material. The dielectric used inside the capacitor to separate the conductivity plates is not a perfect insulator, resulting in a very, very small current flowing or leaking through a dielectric due to the influence of a powerful electric field built by the charge on the plates when applied to a constant supply voltage. How a capacitor will store energy? In the form of electric field, yes? In the form of electric field. That means there is a charge accumulation on the two plates. That means either a negative or a positive charge. So that charge will create electric field, and due to that electric field, there may be a leakage current. This small DC current flows in the region of a nanoamps. it may be a nanoamps, is called a capacitor's leakage current. This is called a capacitor's leakage current. This is called a capacitor's leakage current. Leakage current is a result of electrons physically making their way through the dielectric medium around its edge, or it may be across its leads, and which will over time fully discharge the capacitor if the supply voltage is removed. If the supply voltage is removed, it will discharge. If there is a leakage without any applying a load, it may discharge. So we should consider these characteristics while we are buying a capacitor from a market. We should observe how much the leakage current is it, how much the leakage current, how much the leakage current. When the leakage is very low, such as in the film of or a foil type capacitors, it is generally referred as insulation resistance, or RP. We call it is insulation resistance, and can be expressed as a high value resistance in parallel with the capacitor, as shown here in this, when the leakage current is high, it is referred to as a leakage current, as electrons flow directly through the electrolyte. Capacitor leakage current is an important, very important. It is very important parameter in amplifier coupling while we are coupling a amplifier circuit or in a power supply circuit with the best choice for a coupling or storage applications, being it may be Teflon and other plastic capacitor types that may be polyvalent or polyethylene etc. Because the lower the dielectric constant, the higher the insulation resistance. So you should consider the leakage resistance, the leakage current, the leakage current of a capacitor while we are buying from a market. The other characteristics is a working temperature. Changes in temperature around the capacitor affect the value of the capacitance because of change in the dielectric properties. The dielectric properties of the dielectric material will change within a change in temperature. If the air or the surrounding temperature becomes too hot or too cold, the capacitance value of the capacitor may change so much as affect the correct operating of the circuit. The normal working range for most capacitors is between minus 30 degrees centigrade and 125 degrees centigrade, with nominal voltage rating given for a working temperature. A working temperature of no more than plus 70 degrees centigrade, especially for the plastic capacitor types. Generally, for electrolyte capacitors and especially aluminum electrolyte capacitor, at high temperature, that means at high temperature, it may be plus 85 degrees centigrade, the liquids within electrolyte can be lost to evaporation. As you remember from electrolyte type capacitors, there is electrolyte inside the capacitors as a dielectric. So at high temperature, the electrolyte may evaporate, and the body of the capacitor, especially the small size, may become deformed due to the internal pressure and leak out. Also, electrolyte capacitors cannot be used at low temperature below especially minus 10 degrees centigrade. As the electrolyte jelly become freeze. So the working temperature is very important for very important characteristics of a capacitor. The next topic is about capacitor color code. Like that of a resistor, a capacitor color code is there. Let's introduce you about this capacitor color code. There are two common ways to know the capacitive value of a capacitor: by measuring it using a digital multimeter, or by reading a capacitor color code printed on it. It may be printed on it. On the capacitor itself, there is a code printed, or either you may use a digital multimeter to read the capacitance value. There are two options. This color band represents, especially if the color is printed on the circuit, these color bands represent the capacitance value as per the color code, including voltage rating and tolerance. It will indicate the voltage rating as well as the tolerance. This is printed. Sometimes the actual value of the capacitance voltage or tolerance are marked onto the body of a capacitor. The body of a capacitor in the form of alphanumeric character. It may be by a letter, that means it may be by a letter. However, when the value of the capacitance is of a decimal value, problems are raised. If it is a decimal value, it may be 0 point something microfarad. So during that time, there is some problem. The marking of the decimal point, as it could easily not be noticed, resulting in a misreading of the actual capacitor value. Instead of letters such as P, pico, or N nano are used in place of the decimal point to identify its position and the weight of the number. For example, a capacitor here, as you can see here, it may be N47 means 0.47 nanofarad. For N7 means 4.7 nanofarad, and for 47N means 47 nanofarad. So it is ambiguous to read. Also, sometimes capacitors are marked with a capital letter K to signify a value of 1000 picofarad. If it is K, it is 1000 picofarad. For example, a capacitor with a range of 10K would be 100 times. It is K means 1000, so it may be 100 nanofarad, like this. We may like this, but to reduce the confusion regarding letters, numbers, and decimal point, an international color coding scheme was developed many years ago as a simple way of identifying capacitor values and tolerance. It consists of color bands in a special order known as commonly as a capacitor color code system. A capacitor color codes are simple and effective visual way of identifying the capacitance value of a capacitor. This is the table. In the first table, it is the first digit A and digit B. If it is black, brown, red, as it indicated in the table, as it is already indicated in the table, you can easily read from here. If it is black capacitor, 00 means the first digit A, digit B is 0, and the third digit is a multiplier, and it may be either the last one, it may be tolerance, or it may be the voltage rating. The voltage rating also included in the rating, I mean in the color code. For the time being, it indicates A, B, D, V. The first A is the first digit, B is the second digit, and D is it may be the multiplier, and the last one is the voltage rating. So you can, by easily reading the color codes, you can refer from the table and you will easily identify the magnitude of the capacitors. The magnitude of the capacitors what we have in your hand. Is that clear? Okay. If you have any doubt, you can put any question on the comment box and I will prepare another video. It may indicate a voltage. This one is a voltage rating also. The voltage rating is indicated in the table also, the voltage rating. As you remember, the very important characteristics of a capacitor is it is voltage rating. So the voltage rating also will be referred by using this table. By using this table, we can easily identify the voltage rating of a specified color code of a capacitor. You can easily refer this table. Thank you very much for your attention. In the next class, we will continue about other topics. In today's class, we have done this one. Thank you for your attention. Don't forget to like, share, and subscribe my YouTube channel.